So welcome everyone to this video. Basically, we want to do this question number 2.32, uh, which belongs to the chapter of thermodynamics uh, in the book Irodov. So as per this question, we have 2 moles of certain ideal gas at a temperature T naught. So gas is currently at some particular state uh, where we know its temperature T. Now it's saying that the first gas is cooled isochorically so that the gas pressure is reduced n times, where n is equal to 2.0. So isochoric process means we have to draw a VT graph, and the gas pressure is decreasing without any change in volume. So that means the volume of the gas is constant with temperature, and then the temperature itself has changed from T naught to T naught by n. So this is how the graph is looking like first. This is, let's say, process A. So in the process A, gas has gone from T naught to T naught by n. After that, it is saying that the gas expanded till its temperature came back to its initial value. So in a further isobaric process, the gas expanded to such a temperature that it came back to its initial temperature. So this is process B, which it went through and it came back to its initial temperature. The question asked from us is that find the total amount of heat absorbed by the gas in this process. So we know that in process A, gas will reject heat, and in process B, gas absorbs heat. Right? From the graph itself, it is pretty clear that here temperature is reducing, so gas is going to lose its heat. Here the temperature is rising, the gas is gaining heat. So since we are not uh, doing any kind of expansion in this particular process, especially, uh, so heat absorbed by the gas is heat in the process A plus heat in the process B. In the process A, it's an isochoric process. So we have N, that is moles of the gas, CV, that is the molar specific heat capacity at constant volume, and change in temperature. So our temperature is changing to final temperature T naught by N from the initial temperature T naught. Right, this is the value which we have. Right, this is given to us. Then uh, in the second process, we are given that the gas is going through a isobaric process. Gas absorbs heat isobarically. So in this case, we'll use molar specific heat capacity Cp. And then what is the final temperature? Final temperature is T naught. Initial temperature T naught by N. This is the change in temperature. So if we combine these two expressions, it is pretty easy to figure out that N and T naught by N is a common here, and we have Cp minus Cv of this particular process. So Cp minus Cv for any kind of gas is R, and we are given here that there are 2 moles of gas. So the heat given becomes equal to 2 moles of gas 1 minus 1 upon n 2, t naught into r. So this is the answer for this particular question. If you put the value n equal to 2, you will get rt naught as the final answer. That is clear. This is t naught into r. We have taken t naught as common. So this was the summary of this question. What is the final heat amount added by the gas in this process? So thank you for joining.